Hi, my name is Barry Bowling. I'm an application engineer with Yokogawa's Test and Measurement Department. Today I want to discuss linear scaling, a feature that is important on any scope or recorder, and I'm going to demonstrate how to properly set up linear scaling on the Yokogawa DL350 portable scope quarter. First, I will illustrate using an industrial pressure transmitter with a current output so that it will be clear why we need linear scaling in the first place. Then I'll show you the setup screens on the DL350, and then I'll perform a live demonstration with the resulting pressure transmitter reading on the 350. Okay, so what is linear scaling? Why do we need it? Here's a classic issue with our real-world transducer output, a pressure transmitter. This device takes pressure and converts it to a current. So we go from PSI to milliamps. 0 PSI is represented by 4 milliamps. And in my case, this unit was calibrated so that 14.5 PSI becomes 20 milliamps. So it's a 4 to 20 current loop. When we take the shunt resistor and put it on a recorder or a scope, such as the DL350 portable scope quarter, I'm running a 250 ohm resistor there, so it's taking that 4 milliamps and converting it to 1 volt. It's taking the 20 milliamps and converting it to 20 volts. So now I have a 1 volt to 5 volt device. So that 1 to 5 volts represents 0 to 14.5 PSIs. And linear scaling will take 1 to 5 volts and convert it from 0 to 14.5 PSI. That's the basics of it. That's why we need linear scaling. Let's look at how we're going to do this. With a 250 ohm resistor on the output of the EGA series pressure transmitter, again we get 1 to 5 volts, so it's a straight line, it's linear. We want to go from volts to PSI. Here's a schematic. Again, this is a little repetitive, but I just want to show you that we're taking the 4 to 20 through the 250 ohms and getting back to a 1 to 5 volt signal. So the first input method for linear scaling is AX plus B. We've basically written the equation here at the top, PSI equals A times the voltage input plus B. And I've written two equations we'll solve for A and B, and we'll come up with A equals 3.625 PSI per volt, and B equals minus 3.625 PSI. So those are our A and B parameters. On the DL350, we'll plug those into the linear scale settings. We've got, in this case, scaling mode set to AX plus B. We typed in 3.625 for A, and again for B, minus 3.625. I've had to also type in my engineering units here, PSI. That could be anything. It could be Pascal, kilopascal, whatever units that you have. Okay, so the other linear scaling input method is two-point method, the P1, P2 method. P1 is a point. It has an X value and a Y value. So in this case, P1 could be 1 volt and 0 PSI. P2, similarly, could be 5 volts and 14.5 PSI. That's simply 2 points on that straight line graph that I showed you. And it couldn't be easier to put in. You set linear scaling mode to P1, P2 mode, or two-point method, and you plug in each of those four numbers. P1X is 1, P1Y value is 0, P2X value is 5, the P2Y value is 14.5. And I've put in PSI, capital P, capital S, capital I as my engineering units. Okay, once you save that, your end result is linear scaling with units. Here you can see 13 PSI and some change, and up at the very top you see PSI. So that's in DMM mode on the DL350, which you'll also see in the video here in the next scene. So now that you've seen the screenshots of where these settings reside on the DL350, next I will show you a live demonstration of the same setup. Here's the pressure transmitter. It is connected to a hand pump, and it's also connected to the DL350 scope quarter by a pair of wires and a shunt resistor here at the top of the instrument. So this is a pretty simple setup, and now as you can see, I will apply pressure with the hand pump. You can see that the instrument reads out the correct pressure in the correct units, so 12 or 13 pounds per square inch PSI, and also on the flow transmitter I've got 14 and some change PSI, pounds per square inch, and I have the DL350 and DMM display. Is behaving in a similar fashion as a digital multimeter, so we call that DMM mode. I can put it in waveform mode, and that would record for record a waveform. So it's recording a trend line there, which is flat at the moment, and I can let some air out there, let the pressure fall, and that's waveform display mode. So we could make measurements on that. You can see that the instrument can log that for almost any duration that you wish, and that's it. Pretty simple setup here, just a pressure transmitter, the shunt resistor, and the DL350. Okay, now I would like to do a quick review. Today I first explained what linear scaling is and why we need it in an instrument such as a recorder. Then I showed you the basic method for calibrating your scaling factors A and B, and I also showed you a way to simply let the instrument, in our case the DL350, do that for you using the two-point method. And then we looked at some screenshots of those settings on the instrument as well as the end result while scaling a pressure transmitter. And then finally a live demo. I showed you the same pressure transmitter while applying air with the hand pump and the readings on the DL350. So we had the 350 showing you 14 or 15 pounds per square inch. So I hope that this demonstration was useful to you, and please subscribe to our channel for more videos like this.